Hello everyone. In the last class, we have started the capacitor and we have discussed some important concept that how the capacitor, basically how the capacitor started, what is the reason we have to go from the spherical capacitor to a parallel plate capacitor, and we have discussed the things and our discussion has been closed on the energy stored in between a parallel plate capacitor. Now we have also seen that why parallel plate capacitor is very important, because the two things are very important for us for a capacitor, that energy should be confined. Here the energy is confined, that is the first thing which we are very much interested in. Second thing is the dimension is also very small. So yeah, these two things we have understand, and I have also told you that in our syllabus we have only to discuss about the parallel plate capacitor, and the next we can discuss in other than parallel plate capacitor is the spherical capacitor or the cylindrical capacitor. Just we see the formula, that is only in our syllabus. Okay, so let us start with this. Okay, so now whatever the discussion we are going to do from here, everything will going to be related to the parallel plate capacitor. There is no other discussion going to be happen, because in our syllabus we have to discuss only about the parallel plate capacitor, correct? So let us start. So let us see let us see how capacitor charge. Okay, how a capacitors charge. Basically, what is the logic is used to charge a one capacitor. Okay. Just give me 1 minute. Yeah, so we can continue. So yeah, I'm discussing how a capacitor basically charge. So let us try to understand this thing. Okay, we will go very slow. Let us suppose there is a one switch is there at this point. Okay, please try to understand the things very properly and try to like grasp it at one point, because I am going very slowly for you only. Otherwise generally I don't teach that much slowly. Okay, so try to understand the things very properly. Okay, and let me put here a one battery. Okay. Yeah, so this is a capacitor. I'm talking about initial condition. Initial condition. Let us talk about initial condition. Just try to understand the each and every line, okay, which I'm going to tell you here. Let's talk about initial condition. What do you mean by initial condition? This initial condition means that initially, see, there is a scenario that is, let us take scenario that is t is equal to 0, 0, just like 0 minus means what? Let us, this is our time. Okay, this is t equal to 0, 0 plus means slightly greater than this, like slightly greater than 0, like 0.00001 second, like that. So this is 0 plus, and here means 0 minus means slightly less than 0, correct? So that type of scenario I want to take. Okay, I want to take that type of scenario. So I hope you understand what do you mean by t0 minus. T0 minus means slightly less than 0, means I am talking about past. Okay, so that is a, what is the initial condition? Initially what is given, the switch is open. Initial thing is switch is open. Okay, switch is not closed, switch is open. Okay, switch is open, that is the first thing. Switch is open. Okay, no issue sir, switch is open means the switch position is like this, correct? It is open, correct? Okay. If switch is open, and what is the another thing, capacitor is not charged. 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 If you understand this thing now, I'm guarantee your whole capacitor is finished for you. Okay, there is nothing in this. So initially capacitor is not charged, means if it is not charged, what is the total charge on the capacitor? That is C into not charge, means the potential will be 0, because When the capacitor will be charged, then there will be a potential. So what is the initial charge on the capacitor? 0. That means the total initial charge is 0, initial potential is also 0. Both things are 0, correct? That is the initial scenario. Okay, let's take the another case. That is the initial scenario. Okay sir, I understand what is a scenario at past, in past. Okay, in past basically. Now let us take the another case, sir. Okay, what is the another case, sir? Let us see what is the another case. Let us see what is the another case. Yeah. Now what I am going to do now, is I am just going to close this switch. Initially this switch is closed, means the switch is open. Now at t equal to 0, means at exactly t equal to 0, I have just closed this switch. I have just closed this switch, means the switch has been closed now. This switch has been closed. Now let us think what is going to be happen then. If, okay, suppose the switch is closed, then what is going to be happen? See, one thing we know, will be 0. That thing we know now. This much amount of circuit theory we know, because that's why I have covered current electricity first. Okay, this will be V. Okay, this will be V. Okay, this will be 0. Correct. Can you tell me, or just I am doing one small change, because it will be easier to understand you the things better if just I do the one small change. The thing will be remain same if I am not doing this change, but just for you to understand better, I am just doing a one small change for you. Okay, you will understand the things more better way. Okay, let us the battery polarity for now. You can understand by this by more better way. Okay, just for that I am doing the change. Okay, this will be 0. Okay, this will be 0. This will be 0. Correct. This will be V. This will be V, and this will be V. Now, can you tell me one thing? As I just on the switch, whether the capacitor will get charged instantly? Just think about it and tell me. As I on the switch, the capacitor will charge instantly to voltage V. Is it going to be possible? Is it will be going to be possible? Answer is no. It will take some time to get charged. Okay, so initially just I am talking about t equal to 0. I have just closed the switch. So initially it will take some time. So initially just as I just closed the switch, here there will be no charge will be there, because no potential, because it will take time now. So I am just talking about at t equal to 0, means at that instant only, what is the potential across this? This will be 0, because just you close the switch, it will not get charged instantly. It is not like that. Okay, so there will be current will be there. What is the current? The current will be V by R. Correct. So what we have seen at t equal to 0, as you close the switch, as we close the switch, capacitor not get charge instantly. Okay, instantly. It will take some time. Sorry. Yeah, it will take some time. It will take some time. Obviously, it will take some time. Okay. And the current will flow. At that time, we have a I that is not equal to 0. That is V by R. Okay. Not equal to 0. Okay. Not equal to 0. The value is V by R. Okay. That thing we know. Okay. This much I hope you understand. Now let us talk about another scenario. Now suppose what happened after some time t. Sorry. Let us take a scenario where what happened, now the switch is closed. Okay, but what we are trying to say, okay, Now the switch is closed, t equal to 0. Let some time passes. Okay, let some time passed. At some time t equal to t. Okay, I'm talking about at some time t equal to t. Correct? T seconds. At some time t. What you will see, sir, it will start charging. Some charge plus q, some charge minus q will be on this plate. Why minus q? Because it is connected to negative, correct? And some charge plus q will be on this plate, correct? And there will be some potential will be there. What is the potential? Plus minus how much? That is q by c potential will be there. This will be zero potential, sir, so this will be how much? Minus to plus, so q by c potential will be here. This will be v. So what will be the current will flow? The current will flow here is v minus q by c divided by r. This much amount of current will flow. At some instant I am talking about. This is at some instant. At some time t. At some time t. At some time t. At some time t seconds. T seconds. The current through the capacitor, you can say, or resistor. Basically it is better to say at capacitor. Why resistor? I'm not saying. I will tell you the reason also. But right now you just say it is a current through the capacitor. You can say resistor also, not okay. It's okay. But it's a basically current across the capacitor. What is V minus Q by C divided by R? This is a some you can say you can say this is a current in the capacitor at a some time t. And this is the what? This is a charge at the capacitor sometime t. Are you getting my point? This is our first stage. We have started. Then we went to second stage. Okay. Then we have went to third stage. Okay. Correct. These are the three stages we have seen. Okay. Till here, no one have a doubt. Can we proceed further? Okay. So yeah. Okay, sir. The capacitor has reached to this state. Okay. Then what? Okay, so let's see the another thing, another picture of it. So suppose now I'm talking about last state. Now stage 4. In stage 4, what happened? Let's it reaches a steady state. Steady state means at t equal to infinity. Steady state. T equal to infinity. Okay, so what is going to be happen at t equal to infinity, sir? See, these are the things you have to understand properly, because this is how this circuit element behave. It is a behavior of a circuit element, so you have to understand this. Okay. So what is going to be happen? See, this is a capacitor we have, and this is the resistor we have, correct? And this is what we have, a battery, and we have connected it, we have closed the circuit. Okay, so what is at t equal to infinity is going to be happen? This is V, this will be 0. At t equal to infinity, one thing is sure, at t equal to infinity it will charge to its maximum value. Correct? At t equal to infinity, it will charge to its maximum value. Correct? And what is the maximum value? Which is going to be charged? It will charge capacitor. Obviously, capacitor going to be charged to its maximum value. Maximum value here is potential V. Here in this case, it is V. It is not always V. So the potential V will be developed here. So if it is charged to potential V, means potential V. So the here potential is also V. Here also V. Can you tell me what is the current now in this case? The current will be how much? 0 by R. That is, the current is 0. So now the current will become 0. So as you can see now, as it is reaching the steady state, the current across the resistor is becoming 0. The current across the resistor is becoming 0, means what we can predict from here. Okay, what we can predict and what is the analysis we have understand from this, doing this thing. If you see this thing, you will understand there are the two cases of capacitor we have. One is t One is called as a steady state and one is called as a transient state. This state is an initial condition. These are called as an initial condition. So what is the conclusion we can draw? Okay, so I can say, sir, I can, if I am a student and I have to draw a conclusion, what conclusion I will get? A student conclusion. What a student should conclude from here? Student conclusion. Sir, basically, if we see, sir, according to student conclusion, we have a three conclusions, sir. Okay, sir. What three conclusion? Sir, one is a conclusion regarding initial condition, initial state, sir, or you can say initial condition, sir. Sir, one conclusion I have related to transient state where it is still charging. Okay, transient state. Forgive me if I do mistakes in the spellings. Okay, and the last is, sir, steady state. Steady state. Okay, sir, what is steady state? Sir, what is initial condition? In initial condition, we have seen that if my switch is closed, the switch is closed, and if there is a battery, we have seen that the, oh, let me make it more simple for you. What we have seen basically, if you try to understand in the steady initial state, let us come here. We have seen that if I close this switch, we have find that this capacitor is present here, or whether it is not present, it doesn't matter now, because why? The capacitor potential is zero. There is no charge, nothing is there. So is this capacitor matter in the circuit? Answer is no. What we can say about this capacitor? This capacitor is behave as what? It will behave as a short circuit. So in this case, the capacitor got short circuit. Means whenever we will see about the initial condition, we have to always short circuit the capacitor. Whenever we are talking about initial condition, we have to always short circuit the capacitor. Why? Because initially the capacitor will be always uncharged. I'm giving this statement, but it's a contradictory statement. There are the type of questions can come where initially the capacitor have some charge, but in our syllabus, in your syllabus, this type of question generally don't exist for you. Okay, because otherwise it will become more complicated for you. Okay, so initial state means we have to replace the capacitor by a short circuit. Simple. Replace capacitor for the capacitor got short circuit, or you can say replace a capacitor by a short circuit. Okay, you can replace a capacitor by a short circuit. By a short circuit. That is the thing. What is the steady state? In a steady state, what we have seen, sir, that the current in the branch becomes zero. That means what we can say? We can say the capacitor is behaving now behave as an open circuit. Yes or no? If I remove this capacitor, it will be open circuit, the current will automatically become zero. Correct? So I can say in steady state, a capacitor replaced by a open circuit. If I ask you one thing, I hope you all will able to answer. In which state the capacitor will be maximum charge? And transient is between these two. And this we will discuss in very detail. Okay, this will be discussed in very detail between these two. If I ask you in all these three states, in which state the capacitor is maximum charge, what you will tell? In which of the state the capacitor is maximum charge? Obviously steady state, because all the potential will come, the maximum potential will be there only, correct? So in steady state the capacitor will be maximum charge, correct? If it is like that, so if I ask you in this way, in here only, if I ask you one question, sir, what will be the maximum charge on the capacitor? Because if the capacitor is maximum charge, then what is the maximum charge on the capacitor? The answer is C, that is a capacitance into potential at steady state. Steady state across what? Across whom? Steady state across capacitor. Just take care of my each lines very properly. It is a defined as a potential across the capacitor in steady state. That is an important definition. So if it is like that, I can give you any circuit and I can ask you, okay, tell me what is the maximum charge on that capacitor. So obviously first thing you have to think about that, it will be happen only if it is a steady state, then only it will get maximum charge. Second thing, if it is a steady state, we have to replace the capacitor by a open circuit, and then we have to calculate the potential, and then we have to, that's why I have covered the circuit theory, or you can say current and electricity earlier, because all the concept whatever we are read in the circuit theory, all the things are going to be come here. Okay, so just take a note of it. We will solve some example and we will learn about some more concepts. And let me ask you one more thing. Let me ask you one more thing here. One more conclusion we can draw. There is no space, okay. I don't want to, I want to put everything in one page so that this all will become a short notes for you, because otherwise you will be, yeah. Okay, so let me ask you one thing, one more thing. This thing is clear to everyone? Okay, so let me ask you one more thing. If you see at t equal to 0 minus, or you can say, or 0 plus whatever 0, okay, what is the initial energy of a capacitor? Initial energy of a capacitor, what is the initial energy? Can you tell me here? Can you tell me what is the initial energy of the capacitor? The initial voltage is 0, so half CV square or half Q naught square C, whatever you can use by C. So initial energy will be 0, correct? No doubt. What is the final energy? Half. What is the capacitance C, and what is the potential now? That is V square. Okay. Sir, and what is the there is a battery, correct? Battery also have done some work. What is the work done by the battery? Or battery also provides some work not done a work now, because battery is doing a work here. So what is the work done by battery? Work done by battery, can you tell me what is the work done by battery? See, the formula for work done by battery, if you remember, it is charge flown into potential of a battery. What is the charge flown? See, initially if you will see, here, initially what is the charge flown? The initial charge is 0 here on this plate, correct? Because initial charge will be 0 because no potential. Now it is charged to some potential V. So what is the charge on this plate? Minus CV. What is the charge on this place? Plus CV. So how much charge is flown from 0 to minus CV? How much charge is flown? 0 to, or you can say 0 to plus CV. You can see like that also. 0 to plus CV. How much charge is flown? CV. Correct. So charge flown is CV. What is the potential? That is V. So what is the work done by battery? CV square. Okay. One more thing. Battery is providing a energy of CV square, correct? Or work done, whatever you say. And the capacitor getting an energy of half CV square. So where is the half energy is going? My question is, where is the half amount of energy is going? Where is that energy has gone? Who has taken that half energy? Resistor. So that energy has been lost as a form of heat in the resistor. So half of the energy, half. So what is the energy loss? If I ask you, simply we can write like energy loss is equal to how much? Half, sorry, work done by battery minus half CV square, that is half CV square energy has been lost, correct? This amount of energy has been lost. So what we have to understand is that whenever we are seeing a one capacitor, there should be something in your mind that this whole process has been happened, then we got this capacitor like this. Okay, if I am drawing something like this for you, your capacitor is connected here with directly with a battery of 5 volt, and then plus minus some 10 volt and 2 microfarad, something like that. You have to be clear by this that there will be a resistor in this circuit also, because that resistor is there, and that resistor has been removed because it reached the steady state. Okay, because in the steady state there is a no meaning of resistor. Are you getting my point? Why? Because it will become complete charge now, the current is zero. So what is the meaning of resistor then? Resistor is only valid then when there is a current. If there is a no current, then can you tell me what is the meaning of resistor then? No meaning of resistor, correct? Okay. Okay, so as I have asked for you that what is a heat loss, can we write the formula for this? Heat loss, what is exactly, or let me start with the example. We will see the formula later. Just first try to use your some common sense and solve some question. Okay, I hope you understand the concept. Okay, and everyone has got the concept what I am trying to tell them. So let us see some examples, and then we will make our concept more clear. So suppose this is a, or this is a some 2 volt of battery, correct, and it is connected to, just let us take, it's connected to a capacitor. Initially the voltage across the capacitor is let us take it as V volt, and like the situation is like this. Okay, my question is, obviously initially there will be resistor, correct, in the circuit, so some amount of heat loss must be happen there, correct? Obviously my question is that find heat loss, how much heat lost is there? My question is how much heat lost is there in this example? Can you tell how much heat lost is there? Just note it, just try to solve it and tell me what is the amount of heat lost is there. Just try to think, it's a very common sense. See, what is exactly the heat losses? Okay, what is exactly the heat losses? Heat loss is nothing but, heat loss is nothing but, if you try to understand, it is the work done by battery. And what is the work done by battery? I told you, minus, what is this? It is energy, final energy, E final minus E initial, correct? This is only we are doing na, for calculating the heat loss. That is a general formula. Now let us see in this case what is the, this is the important formula which you have to remember. Now let us see the solution. See, this is the initial condition. What is the initial charge on this plate? That is plus CV. What is the initial charge on this plate? That is minus CV. Automatically what is going to be happen in steady state? By common sense, what you know, like obviously this will become charged to 2 volt, correct? Are you correct or not? Obviously it will go into a steady state, so it will charge to plus minus 2V, correct? And suppose this is the thing is going to be happen or not, plus minus not, yeah. So obviously this will this capacitor will going to be charged to minus plus 2V, correct, because minus polarity is connected to this and plus polarity is connected to this. So what is the charge on this plate? This plate will charge have a 2CV, correct, and this will be charge of it plus 2CV, correct? So first you tell me what is the initial energy? Half C into what is the voltage? That is V, plus that is sorry, not plus, this is half CV square initial energy. What is final energy we have got after a steady state? What is the final energy we have got? Half C, what is the voltage? 2V, correct? So this will become CV square. So energy has been increased, correct? Okay, no problem. Now next is what is the work done by battery? That is charge flown. How much charge is flown from here to here? How much charge has been flown? You can see the initial charge on this is 2 minus CV. Now the charge is plus 2 CV. So how much charge is flown? How much charge is flown? Final charge minus initial charge, 3 CV, correct? What is the potential? 2V. So it will become 6 CV square. So what is the heat loss here? How much heat is lost? That is 6 CV square minus, obviously final energy minus initial energy, that is half CV square. So if you subtract, how much you will get? 6 minus 0.5, that is 5.5 CV square. That is a heat loss in this. Have you got the answer? Have you understand the concept? That is what is the logic we have to use to solve the question. If you understand, just solve another example for me. And remember, heat loss can never be a negative quantity, because if you bring us some negative answer, that means you have done something very extraordinary thing which cannot be possible in this world. Okay, so just take care of that thing. It can't be possible. You can't bring the heat loss as negative. It will be always positive because it is across the resistor. Okay, resistor is a passive element, it's not an active element. Okay, yeah. In this question again, my question is same, heat loss, how much heat is lost in this. Let me take one more example. Hmm. Same question, heat loss. Okay, solve it. Yeah, solve this. Till I am writing one more example for you, or let me write on the next page. I hope you note down. Okay, so solve it and calculate the heat loss. The question is same in everywhere. You have to calculate the heat loss in every question, correct? Yeah, now I am changing something. This is 3 microfarad, this is 5 volt, and it is 2 microfarad, and this is how much? 10 volt. Here again the same question, what is heat loss? Correct. Another one example. This is 1 microfarad plus minus 7 volt. Okay, again the same question, what is heat loss? Okay, so how many questions? 2 to 4. Yeah, let's add some more questions, some good question. But let's first solve this, then I will add you some more questions. Yeah, so what is a heat loss for this? Just think and tell me what is a heat loss. You have a, I have given you the sufficient time. Just think and tell me what is a heat loss. What is a what you have to do simply? You have to analyze the circuit at a steady state. Yeah, correct or not? So let us analyze this at a steady state. At a steady state, what is going to be happen? Initial energy, I can tell what is the initial energy, half C, that is C, V square is 2V square, correct? Correct or not? It is 2V square, so it will become half 4 square, that is 2CV square, correct? And what is the final energy? So for final energy, that is sure the capacitance voltage will be how much? This is 6V, so this will also become 6V, correct? And what is the capacitance? That is C, so half CV square, so this will become 36. 36 to 118 C V square, correct. And what is the work done by the battery? If you see, that is, what is the potential? That is 6B, sorry, yeah, no, correct, 6V into how much charge will be flown. See, on this plate the charge is 2V. After this becomes 6 volt, what is the charge on this will become 6V, correct. So how much charge has been flown? 4V, not 4CV. Initially the charge is 2CV. Now the 6CV potential will come. So now the charge will become plus 6CV. So what is the charge will flown from 2CV to 6CV? 4CV, correct. So how much it will become? 24 CV square. So what is the heat loss then? Heat loss will be 24 CV square minus, what is final energy? 18 CV square minus 2 CV square, that is 16 CV square. And 24 minus 16 is how much? Can you tell me? Yeah, it is 8 CV square, correct. Now let us come to here. If you will come here, again we have a same thing, we have to do the same thing, correct. What is the initial energy? That is half CV square, correct. Half C V square, that is 2V square. So this will become how much? Half C 4V square, that is 2CV square, correct. Any doubt here? Till here, anyone have a doubt? Now what is the final energy? Again, the final energy is how much potential it will get. See, this is minus, this is plus, so this will become minus V volt, correct. If this will become minus V volt, you think logically this will become minus V volt, correct. So what is the final energy? Half C V square, correct. So that is 0.5 V square, CV square, correct. Now the energy is decreasing. I have seen here the also energy is increases. In this example also the energy increases, but in this example, sorry, yeah, in this example also energy is increasing, final energy is increasing, but you can see here in this example the energy is decreasing. Why? Because if you see here the capacitor is charging the battery, here the battery is not charging the capacitor, here because the potential of capacitor is more than the potential of battery, correct. So what is the work done? See, initial the charge on this plate will be plus 2 CV. Now the charge will become CV. So how much charge has been flown? Minus CV, correct, into V. So that is minus CV square. Are you getting my point? So now you will calculate the heat loss. So what is heat loss? Minus CV square minus what is final energy? 0.5 CV square. This is minus 2 CV square, correct. So this will become minus 0.5 minus 2, that is minus 1.5, minus 1.5 plus the 1.1 will be getting, so heat loss will be 0.5 CV square. So I hope you understand the thing that heat loss can never be negative, it will be always positive, because it is loss across the resistor, and resistor is an active element. So if you are getting negative value here, that means what is a mistake you have done? You have done the mistake in charge flown, correct. Just correct that. It is minus CV charge flown is there, not plus CV, because here the battery is getting charged, okay. Here the battery is getting charged, here the capacitor is not getting charged, because the battery voltage is less than capacitor voltage, obviously. So how can a capacitor will be charged by a battery whose potential is less than the capacitor potential? Is it possible? Answer is no, okay. So let us come to this example. Yeah, this is the one more case, like you can charge a capacitor by another capacitor, simple thing. If you understand that example, here you can also see here this capacitor will try to charge this, okay. But there is a format of solving this question, there is a short trick also, but I'm prefer to not tell you the short trick. Why? Because if I add suppose 5 capacitor here, then that short trick will be not valid, okay. So it is better to use the concept. What concept is saying, and I tell you that always follow the concept which I am telling, because here if you apply the short trick you will be fail if I make the question with 5 capacitor, 6 capacitor or 7 capacitor, okay. So that's only follow the concept. What is the concept is saying? See, one thing is clear, that what is going to be happen as I will connect. So what is the charge on this plate? So the charge on this place is plus 20 microcoulomb or whatever it is, but I am writing plus 20, okay. Charge on this will be minus 20. This is the initial condition. The charge on this is plus 15, correct, and this will be minus 15, correct. What is going to be happen as you will connect this? The charge will start to flow, okay, from somewhere. because the charge flow will be taken. I know that this is a higher potential, so obviously this will try to charge this. Obviously some charge will be flown from here, correct? And it will enter like this. This is the whole scenario going to be. So if the charge will flown, then what is the charge on this flow plate will be 20 minus q, correct? What is the charge on this plate? It will become, then it will become 15 plus q because it is entering. What is the charge on this? It will be minus 15 minus q, correct? And what is the charge on this plate? In this plate it will become minus 20 plus q, correct? If suppose the potential across this is plus minus v1 plus minus v2, we can sure one thing. If you apply a kvl in this loop, what is kvl? That is plus minus v1 minus plus v2 is equal to 0, or you can say v1 should be equal to v2 in this loop, correct? What is v1? I told you what is v1. v1 is a potential across the capacitor, and what is a potential? That is q by c. What is q? Q is the charge on the positive plate, that I have told you, if you remember. So what is v1? v1 will be, that is 20 minus q divided by c. What is c? That is 2 microfarad. Okay, divided by what is v2? v2 will be 15 plus q divided by 3. Let us solve this. It will become 60 minus 3q, that is equal to 30 plus 2q. So this will become how much? That is 5q is equal to 30, correct? Any doubt? So what is my q? Q will be equal to 6 microcoulomb. So that much amount of charge has been flown. If that much amount of charge has been flown, what is the charge on this plate will be 20 minus 6, that is 14 microcoulomb, correct? So if it is 14 microcoulomb, and what is the charge on this plate will be? That is 21 microcoulomb. So what is the potential then in this case? What is v2 will become? v2 will become 21 divided by 3. The potential is what? Q by c. Now 21 divided by 3, correct? How much it will become? 21 divided by 3, that is 7 volt. And what is the voltage in this case? If you will see v1 will be how much? That is, I think that this is 14 and this is 2 microfarad, so this will also become 7 volt, because what we have seen that v1 and v2 should be equal. So yeah, we see, you can see we are getting equal value. Okay, are you getting my point? What you have done, that is a step you have to follow. In this step you are doing the question, then it will be correct. I am giving you this as a homework. Okay, so oh sorry, we have to calculate heat loss na? Yeah, so what is heat loss in this? See, what is heat loss? See, what is there is any batteries there? No. So work done by battery is 0. What is E final minus E initial? See, E initial is what? First you calculate E initial. If I want to calculate my E initial, half, what is the capacitance? That is C into V square. What is the initial voltage? That is 10 volt. Plus half, what is the capacitance? 3. Initial voltage is 5 whole square microjoule. This is the initial energy. What is final energy? That is half C into 7 square, correct? Plus half into C into 7 square, correct? E final minus E initial you will do, you will get the correct value, correct? This is my E final minus E initial. That is the answer for this. Clear? I hope you understand the concept how to calculate. So this is the homework for you. You have to calculate the energy lost or heat loss in this case, correct? Any doubt here? Anyone have a doubt? Please let me know if anyone have a doubt in this. No doubt? Clear? Okay, so let us take one more example. Okay, why I am telling you have to comment this answer in the comment section. Okay, let us take one more example. Yeah, this we suppose we take a 2 microfarad. This is 2 volt, correct? This I have taken suppose 1 microfarad, and this let me take it as some 4 microfarad, and some again 2 volt or 2 volt, 1 volt. Okay, my question is that Same question, what is heat loss? Now can you tell me what is heat loss in this? How will you solve? Again same approach. We will go step by step. Sir, this plate will have how much charge? That is 4. This plate has a charge of 4 microcoulomb. So let me write it as 4. No issue. Let me write it as 4. That is 4. This charge will be minus 4. Correct. This is initially no charge is there because it is uncharged. So this here will be 0. Here will be also 0. Correct. Now what is the charge on this? The charge on this will be plus 4 and this will be minus 4. Correct. So one thing is clear. This is plus minus V1. This will be plus minus V2 and this is plus minus V3. That is the thing. So if we apply the KVL, I will write as V1 minus V2 minus V3 equal to 0. That is V1 equal to V2 plus V3. Now here you can see in this case V1 is not equal to V2. So that's why I told you I am not going to tell you the short trick, because if I add large number of capacitor, then in that case the short trick will be not valid. Okay. So that is a condition. Now let us apply this thing. What find V1? So what is V1? So for that let us consider the charge flown is Q here. So it will be 4 minus Q. This will become 4 minus Q. Correct. This will become Q and this will become minus Q on this plate. Correct. I am just considering the positive plate. This is 4 plus Q. Correct. So what will be is going to be 4 minus Q divided by 2 plus not plus, it's equal to how much? That is Q by 1 plus how much? That is 4 plus Q by how much? 4. Yeah. So just multiply by 4, you will get how much? 8 minus 2Q is equal to 4Q plus 4 plus Q. That is 5Q. So 8, 4, that is 4 is there. 5 plus 2, that is 7Q. And what is Q? Then it will become, that is 4 by 7. Now once you get the Q, can you calculate the final energy minus initial energy? That will be my work done. Correct. Heat loss. Correct. So just what you have to do now, this thing you can do, you have to calculate E final minus, sorry, that is a heat loss in this case. Correct. So that is how you have to do the approach. The steps are same. If you're seeing the steps are same, if this type of question is coming into the picture, so you have to be very much clear in the mind that what type of question you have to solve in what manner. Okay, you have to be very clear. Just I give you the understanding. Let me give you one homework on this also. You can take this one. Suppose I connect a one capacitor of 3 microfarad and the potential is 5 volt, and another capacitor of 2 microfarad and the potential is 1 volt, and another capacitor of 6 microfarad and the potential is 0 volt, and the let it be like this. Okay. If I want, I can connect, I can do one more thing. That will be very good question. Not a question, but it will be mathematical, more mathematical. Let us add a 2 volt of battery here. Now you calculate what is heat loss. Okay. This question I will solve in the end of this chapter. Okay. I am giving you proper time. You have to comment me what is the heat loss in this circuit. Okay. That is a, you can say, OG question. Okay. And those person who is going to answer this question correctly, their name is going to be announced here. I will announce the name and also I will show the solution of this. So those who will solve this question very correctly with correct answer and proper steps, they have to put their answer into the WhatsApp group and I will personally check it, and if the answer is correct and method is correct, I will going to announce their name here. Okay. So yeah, just do this question. Okay. So that are the 2 homeworks for you. This is a challenge question, not homework question. It's a challenge question for you all. Okay, challenge question. Okay, clear? You have to put it into the WhatsApp group. Clear? Okay. 1 minute just. So what we have seen in the today's class, we have seen the new concepts, lot of new concepts. We have understand that how the capacitor is going to be charged and what are the logic behind it, and we have seen the picture, and I have completely clear with the picture of what we have not seen this concept till here, that is how what is a maximum charge concept, that we will see in the next class when we will discuss about the circuit theory in capacitors. But this concept we have seen completely, and we have solved some numerical also, and we have seen that how to calculate the different, how to tackle the different circuits. For the next class, I will just tell you, just please revise the complete circuit theory which we have covered in the current and electricity, because in the next class, so all the circuit theory I am going to repeat it. So it's going to be the repeat telecast, so it will be better if you know everything, because that I am not going to teach you again, but a kind of revision we will do. So it is very important. You just, if you come in the next class, just revise the everything what we have covered the circuit theory in the current and electricity, because it is going to be the exactly same whatever we have covered. Clear? So till then, take care, goodbye, and please comment this question in the WhatsApp group. And if you like this session, please like it, share it, and subscribe it. Have a nice day.